Hello.
Hello, sir.
Yes, sir.
Did you manage to connect to ASPEN?
Sir, tempat saya masih internal error.
Pandai saya atur ya. Everyone is here? Yes. So have you tried to use ASPEN over the weekend? Or waiting for this class?
I wait for this class, sir.
Understood. Ni makin dah tengok. We should have like 25 students, I think, for this session. Have you connect your ASPEN?
Already, sir.
Okay, that's good. So open ASPEN plus V10 from the window first. Okay. Think we should wait. Skin. Okay. Wow. See here. Wow. See here. Yeah. Can you see my screen? Wait, wow. Sharing. Okay. So, so for today class, we're going to learn ASPEN plus B10 properties. Properties environment, if possible, simulation environment as well. Actually, I'm using two computers now. One is for ASPEN, the other one is for my slide. So ASPEN stand for Advanced System for Process Engineering. So ASPEN or ASPEN Plus is used to simulate an entire chemical process from raw material to finished product. So the picture below is the figure below is simulation environment, but we start with properties environment first. So first of all, you open your ASPEN? Do you know how to open ASPEN? Go to window, then ASPEN Plus here. Go to ASPEN Plus V10. Just click it. It will show this splash screen. Yeah. That's it. So, ni aku pun slide. Ayah. Oh. So first of all, for chemical engineering, we're going to use chemical processes. There are two type of chemical processes that suit us for Malaysia. I'm using metric units. So the difference between these two uh, processes is the unit. You can see for chemical with metric unit is use temperature is in Celsius, pressure in bar. This is flow rate, mole flow rate. This is for energy balance. Yeah, that is the difference. So after you choose which one, should you choose? After you choose either one, you need to click create. Then this is the environment pane. You see the properties pane is what we learned today. If possible, we go to simulation as well. In this properties, you need to specify the component and the property model, the direction. For simulation, you will create the flow sheet for your process. For safety analysis, energy analysis, this is for advanced, but I will cover until simulation only. Data source step, we just want to, first we familiarize with the button and tab first. make sure you connect to your ASPEN. So the data source tab to seek additional information from data bank. This is analysis, estimation, and regression. Each have different use. Run tab is when you have registered all the chemical component, then you need to run the analysis for to check the binary interaction. So first of all, I'm not sure if you still follow me. Include these three components: water, MEK, methyl ethyl ketone, and 1-octanol in your ASPEN. Let me show you how to do that. Choose either one, this one or this one. And not that, not metric unit, specialty chemical with metric unit or chemical with metric unit. You need to wait for a while. Okay. See anybody? I think most of you can do this until up to this step. So to register the component, you just type water, enter. For MEK, you need to type the name because methyl. Oh, sorry. Go to find first. Click find methyl ethyl ketone. Find now. Okay. Choose the one below. Methyl ethyl ketone compound name. Add selected compound. See here, you have two component. Then the last one is 1-octanol, right? 1-octanol. The first one, 1-octanol. Add selected. Don't replace it, just add. So you have three component now. So you rename it. Just double click. Octanol and MEK. The navigation pane. Navigation pane for properties environment. So did you notice a half fill red? or red white circle in your properties in your navigation pane. It refer to some wait it refer to require input incomplete, so you need to add. So this is the example of symbol in ASPEN. You have like quite a number of symbol, each have different means. Next. Use chemical with not English unit. Metric unit. Metric unit. So next is selecting databases. For selecting databases, just follow this component, specification, enterprise database. So make sure NIST V100 NIST-DRC is added into the selected data bank. If it's not already added, otherwise just leave it. We add this database because it has a lot of data inside. I already covered this, how to add the chemical. Next is to specify the property method. Wait, specify method. Navigation pane, method, specification, and global. Yeah. Just open it, make it bigger. See here, half fill circle. This means it require input. So select it, specification, this one, global. This is global. So choose an RTL as the best method. Other model that worth knowing are UniFAC, Universal Functional Activity Coefficient, and UniQuark, Universal Quasi-Chemical Activity Coefficient. So an RTL UniQuark model would perform well for system with polar compound, low pressure, less than 10 bar. In ASPEN, low pressure means system or process that is conducted less than 10 bar. For equation of state model for non-polar compound and normally for modeling hydrocarbon system, we using Peng Robinson and Redlich Kwong Swa for non-polar compound. So once you select it, this, once you select the method, which one should we use? Wait, Go to parameter, binary interaction. This is an RTL. You already choose it here, the best method. So select an RTL. You see this table, right? So estimate using uniform. That is for water, MEK, water ethanol binary interaction. So do you have any question? This is my first time teaching using online. I'm not sure if you can cope. Is it too fast or should I wait? Already, yeah? Okay. Next slide. Already. Okay. Oh, this is the property method. We're using an RTL. There are other type of model method name. We're going to use few of it in this course, especially when we simulate reactor later. So to improve model accuracy, you need to tick estimate using uniform. Then, first of all, first change your component. Change your component to acetone, MEK, and 1-hexene. You already include the octanol, right? You delete octanol, you replace it with 1-hexene. Go to setup, not setup, component, octanol, delete it, yes, 1-hexene. Now, first one, add, close, rename it, 1-hexene, rename. So go to method again, find the, how to say this, half fill circle, okay? NRTL-1. So estimate using Unifac. If you have slide with you, you click run. Okay. Wait. Okay, finish. So go to that table again and RTL. The half fill circle is turned to blue tick. Right. That means it's the required input is complete. Yeah, you will get this kind of interaction. So the pair between MEK and 1-hexene, this one, MEK and 1-hexene, is estimated by property constant estimation, RPCS. Any question? Okay, good. Next. That one is for run what in analysis. Next one is improving pairwise interaction MEK and 1-hexene using NIST-TDE using a database. So click regression there. So click regression. Ready? So don't forget to unselect, deselect, estimate using Unifact. So you click the regression, click NIST-TDE, this one. Go for binary, because MEK and 1-hexene is estimated by RPCS. If you want a more accurate value, you can use the thermo data engine here. So you choose MEK, 1-hexene, retrieve the data, wait. Oh, gem. Any question? Okay. If it's ready, you will get this how to say window, TDE binary result. So choose binary here. You can close this window. Already, yeah? So consistency, run consistency test. Go back to experimental data. Save the data. Once you do that, go to regression, create new, We have a dr dash. First one, you need to use evaluation first. Don't forget to select dataset. This dataset is coming from NIST that you just saved, right? Calculation type is evaluation. Already, yeah. Then click next. Just run it. See here. Run dr1 is correct. Data regression complete. You go back to your NRTL. Wait, this one, sorry. Ya, sudah. So that's all for properties environment. So for this properties environment, you need to know how to add the chemical, how to choose the method. See a lot of method here. Normally we use an RTL. Then how to do the pairwise interaction. Pairwise interaction. If you're using analysis, so your pairwise interaction, you need to click estimate using unified before you click next. If you want a more accurate data, you need to use a regression. That's all for properties environment. So we do one exercise thing for this topic. It's really hard to teach software using online actually. Classwork 1.1. Let us demonstrate the concept of mixing rule via considering the density of a mixture made of benzene, toluene, aniline evaluated at room temperature 25 degrees C and 1 atm. Using specialty chemical with metric unit temperature at the ASPEN plus file with the following component, benzene, toluene, and aniline. The default property method is RTL. There will be no flow sheet at this stage because this is just properties environment. We will using analysis and estimation mode. There will be no need to use NISTDE experimental data. Hence, the missing variance parameter, if any, will be estimated using UNIFAC under an RTL, the one that I just show you. We'll create two analysis tests, one for pure substance and one for mixture. Carry out the following step. So first you create new specialty with metric units. New ASPEN, no need to close, just You want to close? No. Laptop running slow for Mr. Rizwan. Actually, your laptop is not running this ASPEN laptop. It's computer inside the lab. Maybe the computer is slow. So any question you can post it in chat, I think, if you don't want to talk. Can't open my ASPEN. I don't know how to help you. Actually, yeah. Why? Say that all lesson are currently in use, eh? Oh, okay. It should be okay. I checked it this morning. Even turn you guys into administrator of the computer for each of the computer here. Yeah, 28 working computer. I'm not sure why. Yeah, sure. So we continue with exercise. I will post this video in Elip. So first of all, you need to register to add the component. First of all is benzene. Benzene. C6H6. C add then toluene. Another one is aniline. Alamak. Ah ya. Dah jam lah komputer. Oh. Why we have 29 participants? Should we 25, I think. Yeah. That's why para debug cannot use the ASPEN. Maybe someone else using the computer. That's why. Benzene. Aniline. Yes. Toluene. Toluene. Hmm. Oh, this one I think. Toluene. see. Wait. Don't forget to rename it. Trans 1P polypropene. Okay. So go to method in RTL. Go to parameter, binary interaction, and RTL, estimate. Alamak. Ayo. Analysis. Then run. Hmm? So under properties environment, analysis mode, click on pure analysis. Which one is pure analysis? Oh, this one. Under pure component tab, select thermodynamic as the property method. Okay. And mass RH. Oh, it's the sub property. Select the phase to be liquid. Okay, already. Moreover, select temperature to be 25 degrees C. Temperature. Hmm. Peliknya. Okay. Click. After you done this, click next. Okay. In the analysis pure one, you will be able to see the estimated mass density for each per component, benzene, aniline, and toluene. Under properties, click on mixture analysis. This is for individual. How about mixture? Under the mixture analysis, Enter the required input data shown in figure below for the mixture properties analysis. First of all is, why it's not similar? Hmm. Pressure 1, temperature 25. Five. So do you still with me? I have another 1 hour. Benzene, aniline, toluene, 25. Oh, sorry. Aniline is 50. So the fraction is 1. Then done this. Click next. Go to analysis. Mix 1 tadi. Before this you do pure 1. This is mix 1. So this is the result for mixture density. Density of the mixture of benzene, toluene, and aniline. I think that's all for properties environment. There's no flow sheet. Now we go to wait. Okay. Now we go to we continue with simulation environment. Hmm. Is it? For Paradiba and Jarwan tree, I'm not sure how to help you. Can you do the step-by-step exercise afterward? Oh, not written method. Just do the step by step, or just exercise. Do it on your own. Yeah, you need to do it before you can understand. So we go for simulation. Another 1 hour. Right? 1 hour with ASPEN. You can access this because the license is used because that computer is used by another person. I'm not sure which person inside this class because it should be 20, 25 student plus me. I use 2 account. So now we have like 28 participants. Yeah, maybe some of the student Friday class enter this class. I'm not sure. So pre-setup prior to simulation. Before placing the mixer box, enter 3 component water, acetone, and methyl isobutyl ketone (MIBK). The goal of the section was to separate feed stream into 2 streams that consist of 95% water and acetone respectively. Conduct the binary interaction using an RTL and forget to estimate missing parameter by using pump. User account is locked. Okay. Um. Okay. For those who have access, you connect to your ASPEN, create another file, new. No. Okay. So include 3 component water. Which one is it? A stone. And methyl isobutyl ketone. So rename this MIBK. After you add the component, go to this half fill circle, estimate. Yeah. Next. So there is no error in this control panel. So all the interaction is good. So go to simulation. So once you're in simulation environment, you notice the model palette below. We have a lot of model, vector, column, is a changer. So today we We're going to use mixer, just drag it inside the flow sheet, mixer. After that, you click material to connect the stream. See, we have a 3 stream. First is red stream and the red stream as well. So we need 2 stream going inside, 1 stream going out. So the first stream is mixture of H2O plus acetone, right? Other one is MIBK. The product should be after you do this, click next, go to home. So it will ask you to include the, not to include, to specify stream H2O ACET, H2O acetone. So in this stream, the mass flow rate of water is 50, acetone is 50 as well, temperature 25 at 1 atm. Then you click next. You notice the require input incomplete, right? So that means you need to click next. It will ask you to enter the stream for MIBK. So for MIBK, it's 100 kilogram per hour. It's similar 25 and 1 atm. See here, require input complete. So you click next. Check your navigation pane. There is no half fill circle, half fill red circle, which is good. So go next, then yeah, run the simulation. Check for warning. So no warning issue, no error or warning issue during simulation. It's good. So go to result, stream. Here you can get the properties for all the stream. The mole flow, mole fraction, mass flow. See, water and acetone enter at 50-50. MIBK is 100. Then mass flow for trimmic, the product is 200 kilogram per hour in total, which is mixture of both of all water, acetone, and MIBK. So to save your work, to file, save as compound file. So this one is save it. Similar, that is similar to what I just told you. This one is the result. You should get the similar value, 100, 100, 200. The mass frac is this. So now we're going to run a simulation using different property method, Wilson. So going back to properties environment, method specification, change the method name from NRTL to Wilson. Check the binary interaction Wilson-1. Select the unifact, estimate with unifact and run. After you do that, you go back to your simulation environment, reset it first, then run the simulation. You probably will get this result. It's different, huh? If you use Wilson and RTL or Uniquark for the property method. This one is Wilson, yeah, Wilson. See, Wilson-1, estimate, next, run it, no error, go to simulation. Don't forget to reset, click reset here, okay. Then you run it again. There's no error. Go to result summary, stream. So we go for classwork 2.1. Problem. We have a 50-50 wet percent mixture of water and N-hexanol. We plan to separate this mixture into its constituent and ultimately end up with almost pure stream of water and alcohol. Add component water, 1-hexanol and 1-octanol in properties environment. Retrieve data from an IST TDE and check the consistency result for all binary interaction. A good quality binary interaction should have quality close or equal to 1. If the consistency test result fail, use an RTL property method and estimate the missing parameter. Switch to simulation environment and place block and stream as follow. The total flow rate of H2O 1-hexanol is 100 kilogram per hour at 25 degrees C and 2 atm. The flow rate of hexanol, octanol, octanol is also to 100 kilogram kilogram per hour at 25 degrees C and 2 atm. The mixture exists under the same condition of pressure and temperature. So yeah, you try to do it first. So first of all, create a new no you start with properties environment. So what is it? Water, 1-hexanol. Oh, siapa? Delete. You need to use find. 1-hexanol. First one. Add. Yes. Yes. 1-octanol. One. Add. Rename it. Go to spec. Oh, it's ask you to do NIST, right? Okay. So NIST for all binary interaction. Okay. For all binary interaction. Water when hexanol. So you first you check interaction for water and 1-hexanol. Click NIST, binary mixture, water and 1-hexanol. Sorry. Retrieve data. Lot of data here. Wow. Okay, so go to consistency test. Run consistency test. So you can know the data quality from this column. Okay. Overall data quality. In the classwork 2.1, it said that a good quality binary interaction should have quality close or equal to 1, which is quite far from 1. So don't use it. Yeah, it's not accurate. So we go for which one? Water and 1 octano. Retrieve data. So this one is data for water and 1 octano. Run consistency test. Similar. It's not a good data quality. The last one is 1 octano and 1 hexano. Already. Consistency, run it. Okay. Still, see, the binary interaction is. So in that case, don't use NIST. It's got a trivial data quality. So you go for estimate using Unifac and click next to run it. Complete. You see here. So go for simulation. In the simulation, it said that you want to mix water and N-hexanol. Water, yeah, mix water and alcohol here. So we need to have to use mixer. So just drag it. Click material. You should have 2 input, right? 1 output and H2O plus C8OH. C6 or C8? C6, okay. C6OH. One is C8OH, octanol. One is premix. So after you done this, just click next. Then ask you to, ASPEN asks you to fill in stream C8OH or 1 octanol. It said that the total flow rate of C8OH, this one octanol, is 100 kilogram per hour of pure octanol at 25 degrees C and 2 atm. 1 octanol is 100. Next, click next. This one is for H2O with 1 hexanol stream, similar 25 to. So in the slide 24, it said that we have a 50-50 weight percent mixture of water and N-hexanol. So if the total is 100 kilogram per hour, the mass flow for each component is 50 each. Next. Okay. Run here. No warning or errors were issued during simulation. So go to result summary stream. Mass flow rate inspection. Yeah, see, it is balanced, right? So that's all for class work 2.1. So to do just a bonus, I think. Uh, Azeotropic search. Go to home. This is to check the azeotrope. Azeotropic search. Azeotropic search. Select all. Then click report. 2 azeotrope found. Water and 1 hexano, and water and 1 octano. For this mixture. So, you have any question? Classwork 2.2. We have a 50 we have a 50-50 weight percent mixture of water and acetone. We plan to separate this mixture into its constituent and ultimately end up with almost pure stream of water and acetone. Block diagram as follow. The total flow rate of H2O acetone stream is 100 kg per hour at 25 degrees C and 1 atm. The flow rate of EIPK, ethyl isopropyl ketone, is also 100 kg per hour at 25 degrees C, 1 atm. The mixture exists under the same condition of pressure and temperature. Three component, water, acetone, and ethyl isopropyl ketone, EIPK. Check NIST3E for binary interaction of a water acetone system only. Use NRTL property as best method. Check for isotope after simulation. You try this first. Hmm. For those who still have issues to connect remotely, you can ask Mr. Zulkifli to help. Because this is technical. I don't know how to troubleshoot it. So anyone have any question? It's easy, I think. Yeah, to use ASPEN. Next week we're going to learn which one. I think flash separation unit. I think so. Yeah, distillation column macam ni. So for the classwork 2.2, you start with create a new worksheet. How many worksheet already? 6, 5. Okay, 5. I think this computer still can handle 5. Yeah. So start inputting the component. Yeah, component. Which one is it? H2O, water, acetone. Sorry. Yes. Ya, ada. Okay. Hmm, hmm. First component, VI, we name it VIPK. So the best method is NRTL. So it said here, check NIST3 for binary interaction for water acetone system. Okay, so going to check it. Water, acetone, div data. Okay, check for consistency result, consistency test. Cepatlah. Okay. You search for this one. Binary VLE 102. Because it have overall data quality of 1. 102. 102. 102. So go to experimental data 102. This one. Oh, dapat ah? So 102, you save the data. Okay. Okay. Go for estimation or regression. Regression. New DR1, don't forget. Create new regression. Evaluation. Dataset is VLE102. Yeah. Then you click. Okay. Ready. Eh, Ready, yeah. So next, go for simulation. Mixer. Mixer. Then do input. one output. The first one is H2O plus acetone. The one is IPK. 3 mix. So once you have this completed, as usual, you just click next. Ask you for the IPK. Or in the question, set it 100 kilogram per hour, 25 at 1 ATM. Next, 50% mixture of water and acetone. So we have 100 kilogram per hour. So this one should be 50. Acetone is as well 50. Similar 25. This one. Then run the simulation. No warning, no errors. So go to result summary and stream. Mass flow is balanced, right? 200, enter 200. Outlet, restriction as well. That's a bonus. You can check the Zoetrope search, select all, click report. Zoetrope for water and EIPK only. So I think that's all for today. Managed to finish 3:36. I will share the video later in Ellipse for those who can log in to access ASPEN. So any question? So for preparing this slide, I'm using this book. Try to search this book, PDF. PDF. If you want to learn more, so to conclude, today I you I hope that you understand how to include the component for each of the chemical. The next step is do the binary interaction using an RTL or any other method here. Then click this estimate. That one is for properties environment. For simulation, you need to input all this mixture, mixer, and for both stream. For mixer, because we said that the mixer will follow the feed stream, right? So you leave it 0 ATM. Just leave it. Don't bother to change it. still have time if you have any question. And for assignment, actually Mr. Afizal remind me to tell you that the assignment for his part will be combined with mine, and I will post it in week week 13, I think. 13, yeah. Week 13. So you have simulation and manual calculation as well for assignment. So anything else? Shall we conclude this class? Uh, I hope you learn something. Yeah, exercise it. Try to do as many as you can. Find this book. You can learn a lot from it. Yeah, you have the basic now. How to? Yeah, you have the basic now. At least. So okay. Thank, thank you. Thank you.
Thank you, sir.